Welcome to Math TV with Professor V. In this video, we're going to look at the discriminant and using it to study solutions of quadratic equations. So there's times in mathematics where we don't necessarily want to solve a quadratic equation. All we're interested in is the number and types of solutions that an equation has. And if you'll think back in the previous lesson, we looked at the quadratic formula. And when we use it to consider the solutions to quadratic equations, we can see that the number and type of solutions is entirely dependent upon the value of the radicand. The radicand is the stuff underneath the square root sign in more regular terms. And it has a special name. It's called the discriminant. So I'm going to write the quadratic formula one more time for everybody right here. So when I memorized it, my teacher actually made us come in one at a time, make an appointment with her and recite it. Can you believe it? Okay, so x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And the radicand, okay, is whatever's underneath the radical sign in the quadratic formula, and that's given a special name called the discriminant. So the discriminant is equal to just the quantity b squared minus 4ac. And how exactly is that going to tell us about what kinds of solutions we have? Well, we'll look at it right now. First things first, which we noticed in the previous lesson, if the discriminant, if b squared minus 4ac is negative, is less than 0, then our answer would involve the imaginary unit I, and we would have two complex solutions. Because anytime you take the square root of a negative number, your result is an imaginary number. So if the discriminant is less than 0, then you have two imaginary or complex solutions. And we know we have two of them because later you'll study the conjugate pairs theorem, where basically if you have a solution of the form a plus bi, you always have a solution of the form a minus bi. I always think complex solutions are like little penguins. They go in pairs everywhere. They mate for life. Okay, then other option. Say the discriminant b squared minus 4ac is positive and it's a perfect square. Okay, so that means underneath the radical, you have some number like 25, 9, 36, 81, okay? Perfect squares only. Well, when you take the square root of a perfect square, you're gonna get a rational number, a number that can be written as a ratio of two integers, and we'll have two separate solutions. So we'll have two rational solutions. If the discriminant is positive, and it's not a perfect square. So that means underneath the radical, you have something like 34, 7, 28, okay? It's not a perfect square. No problem, you still have two solutions, but this time they're irrational. If you need a little review on what a rational number is, don't worry, I have a video for you. It's pretty short and sweet. I'll link it right here if you need a refresher. It's definitely a topic that some people need reinforced, so don't feel bad. Also, irrational solutions come in conjugate pairs just like complex numbers. So I'm just going to make a note that you do get irrational conjugates. We'll look at that in a second. Okay? And then the last one is, we've looked at negative, we've looked at positive, we haven't looked at if the discriminant is 0. So if b squared minus 4ac is exactly equal to 0, then you have only one rational repeated solution. So later on, if you're in like pre-calculus, you'll study it and say that the solution has multiplicity 2, because we know since quadratic equations are degree 2, they're going to have two solutions. If you have only one solution, it's basically in there twice. And we'll look at that, don't worry, okay? So here we go. Let's look at these examples here. They say without solving, okay, determine the number and type of solutions for the following quadratic equations. So we're just going to figure out the value of the discriminant, which is b squared minus 4ac. We're not going to bust out the whole quadratic formula. We're just going to compute the value of the discriminant. All right, so to get started, let's list out what the values of a, b, and c are here. A is 1. I don't see a term with x, right? So it's basically x squared plus 0x plus 3 equals 0. So I'm going to say b is 0. And then c is 3. So the discriminant is going to be b squared minus 4ac. And this is negative 12. So look back at the 4 scenarios that I listed up above. Negative 12, that's a negative number, yes? That's less than 0. So that tells me we're going to have 2 imaginary solutions. And that's it. Okay. Next, example B. Let's list out what A, B, and C are. Everything's already written in standard form. So A is 4, B is 8, and C is negative 5. All right, so we've got b squared. B squared is going to be 8 squared minus 4ac. Now, since I'm multiplying by 2 negatives, this is going to make it a positive 16 times 5, positive 80. So this is 64 plus 80, which is 144. So 144, that's positive, and it's a perfect square. So that means we're going to have 2 rational solutions. And right now, we don't care what they are. We're just interested in what kind and how many. Okay? All right, example C, we have x squared minus 7x plus 5 equals 0. So let's list out again. A is 1, B is negative 7, and C is 5. So the discriminant is going to be negative 7, quantity squared. Make sure you put your parentheses around the negative 7. The exponent goes on the outside. Minus 4ac. So negative 7 squared, that's going to be positive 49 minus 20. This gives us 29. So 29 is positive, but it's not a perfect square. This means this quadratic equation will have 2 irrational solutions. All right, very good. Let's look at our last example here. You could probably guess which case it is, right? The one we haven't done. So A is equal to 1, B is equal to 10, and C is 25. So the discriminant is b squared minus 4 times 1 times 25. 10 squared, that's 100, minus 4 times 25, that's also 100, and this gives us 0. So when the discriminant is equal to 0, remember that's when we have 1 rational repeated solution. And I just want you to kind of understand what that means a little bit further. I know we weren't asked to solve, but if we wanted to, we could solve this quadratic equation actually by factoring. X squared plus 10x plus 25, that factors into x plus 5 times x plus 5, right? Or x plus 5 squared equals 0. So when you're solving, you can just solve by factoring using the zero product property. You would get one solution, x equals negative 5, but it's a repeated solution because notice when we wrote it in factored form, x plus 5 was a factor twice. So negative 5 is a repeated solution. We say a solution of multiplicity 2 right there. Okay, so that's what it looks like when the discriminant is 0 and you have one repeated rational solution. Now, we're going to basically go backwards from the process I just showed you and look at how to write quadratic equations if we're given their solution. So before we do that, we're just going to review one more time our factoring method for solution, okay? So when we have quadratic equations and they are factorable, that's the easiest, cleanest way to solve them. And let's review the process, okay? So say you have something like 3x squared minus x minus 4 equals 0. Let's see, that'll factor into 3x minus 4 and x plus 1. And then you set each factor equal to 0. So you would set 3x minus 4 equal to 0. And then you would set the other factor equal to 0 and solve each of these equations separately. And you would end up with x equals 4/3 or x equals -1. So now we're going to basically reverse this process. We're going to be given the solutions, and then I want you to come up with what the original equation was. All right? And let's read the directions carefully. It says, find an equation for which the given numbers are solutions. Write your equation in standard form with no fractions. All right, here we go. So first quadratic equation has solutions 7 and -4. So I'm going to go backwards. I'm going to start basically at this step right here. They're telling me x is equal to 7 or x is equal to -4. Well, back it up. What did it look like at the step up above? Well, we had zeros on the right-hand side. So that would mean before this step, we had x minus 7 equals 0 or x plus 4 equals 0. And then these would be the factors of the quadratic equation. So I could multiply them by each other. X minus 7 times x plus 4. Those would equal 0. Their product is 0. And then multiplying everything out, we would end up with x squared minus 3x minus 28 is 0. So now we've written a quadratic equation whose solutions are 7 and -4. Wow, look it, we could even write a worksheet for an algebra class full of quadratic equations and say solve this, and you would have the answer key because you wrote them all yourself. Such fun. All right, let's look at another example here. Example B, this time the solutions that they gave us were 5 and 1/2. So same process, okay? Start off saying x equals 5 or x equals 1/2. And I'm going to take one extra little step because remember how the direction said no fractions. So when you do have fractions, just multiply that solution, that equation by the LCD. So I'm going to multiply everything by 2. And now I have 2x equals 1. Okay, x equals 5 was fine. Then set each of them to 0. So that means x minus 5 is 0 or 2x minus 1 is 0. Those are each our factors for our quadratic equation. So x minus 5 times 2x minus 1 equals 0. And then you just multiply everything out. So we'll have 2x squared boop, minus x minus 10x plus 5 is 0. So our quadratic equation would be 2x squared, actually I'm alarmingly out of space, 2x squared minus 11x plus 5 is 0. All right. Oh, no, not an arrow. We're not doing vectors in this lesson or anything. Okay, great. Let's look at something a little spicier. We've got some imaginary solutions, 5i and -5i. So same idea. We start off with x equals 5i or x equals -5i. Set each to 0, so x minus 5i equals 0 or x plus 5i is 0. And then those are the factors of our quadratic equation. So x minus 5i times x plus 5i equals 0. Since we have conjugate pairs, when I multiply them out, I'm going to get a difference of squares. So we'll have x squared minus 25i squared equals 0. And remember, I squared is equal to -1. So this is x squared minus 25 times -1 is 0, which means we're left with x squared plus 25 equals 0. Beautiful, beautiful. Okay, last one. And I want you to notice in this case we have irrational solutions, and they are conjugates because we have 3 rad 11 and -3 rad 11. So irrational solutions also come in conjugate pairs, just like complex or imaginary solutions. Okay, same idea. We've got x equals 3 rad 11 or x equals -3 rad 11. Now what's the next step? Good. Set each little equation equal to 0. That'll give us what the factors are. So x minus 3 rad 11 or x plus 3 rad 11 equals 0. And then those are our factors for our quadratic equation. So x minus 3 rad 11 times x plus 3 rad 11 is equal to 0. And then now we can multiply this out. We'll get a difference of squares. So we'll have x squared minus, now be careful, 3 rad 11 times 3 rad 11 is going to be 9, 3 times 3, times 11. Rad 11 times rad 11 is just 11. Woo! And then we can just clean this up. X squared minus 99 is 0. So that concludes the lesson. Hope you found it helpful. Give this video a thumbs up. Leave a comment down below. What was your favorite part of this video? And then subscribe to my YouTube channel if you haven't already. I have lots of videos all the way from algebra through multivariable calculus, a little bit of differential equations and linear algebra I'm still working on slowly. And you can also catch me on Instagram and TikTok at Math TV with Professor V. The next lesson is going to be on solving problems, aka word problems that are quadratic in nature. So stay tuned. Make sure you turn on the notifications bell when you subscribe so you'll be notified anytime I upload, which is usually daily. And I'll see you guys soon. Bye.